ThousandEyes network and app synthetics tests monitor application and network performance by simulating user interactions from vantage points around the world. This synthetic monitoring helps organizations identify and troubleshoot performance issues and outages before they impact real users. Let's start with network layer tests. There are two types: agent-to-server and agent-to-agent. The agent-to-server test measures end-to-end network performance to a remote server from one or multiple ThousandEyes agents, capturing metrics like packet loss, latency, and jitter. They're useful for monitoring application servers, database servers, or any other network-accessible hosts. Agent-to-server tests provide a detailed hop-by-hop path visualization showing the network devices and links that traffic traverses from the agent to the destination server. You can also run agent-to-agent tests, which monitor performance between two ThousandEyes agents, either cloud agents, enterprise agents, or a mix of both. These tests capture metrics like packet loss, latency, jitter, and optionally throughput. You can monitor the path in either or both directions, which is crucial for visualizing asymmetrical network paths. Agent-to-agent tests are useful for monitoring performance across different segments of your infrastructure, like data centers, branch offices, or cloud regions connecting to on-premises locations. This test also offers hop-by-hop path visualization, detailing the network route between the two agents. ThousandEyes offers three types of DNS tests: DNS Server, DNS Trace, and DNSSEC. DNS Server tests monitor your DNS infrastructure and user-provided domains, measuring DNS resolution time and server availability. They're also useful for validating global server load balancing, GSLB, and GODNS systems. The DNS trace test captures trace information from the root servers down to the authoritative DNS server for specified domains. DNSSEC tests validate the cryptographic keychain for the target DNS record and measure resolution time and availability. There are 5 types of web layer tests: HTTP server, FTP server, page load, transaction, and API tests. The HTTP server test helps you detect issues impacting your web servers and services, whether the issue is from the network, server, or other infrastructure components. It measures response time for HTTPS requests along with availability and throughput. The FTP server test monitors the availability and performance of your FTP, FTPS, or SFTP servers, ensuring your file transfer services are running smoothly and reliably. It confirms server availability, successful authentication, and the ability to upload, download, and list directories. The test measures availability, response time, and throughput. In the table view, you'll see details for each agent, including the agent name, timestamp, target IP address, and any FTP error types or details. Page load tests help you identify issues affecting the user experience, like slow loading pages or broken elements. They measure the time a web page takes to fully load and render, including assets like images, videos, and scripts. In the waterfall view, you can see how a browser interacts with each component on the page and the sequence in which they load. Transaction tests simulate multi-step user interactions like shopping online or logging into a website. They act like real users, navigating through web pages and interacting with them through simulated keyboard and mouse clicks. You can use transaction tests for submitting forms like logins and monitoring other complex website interactions. During the test, you can measure the time taken for each step and capture snapshots of the pages along the way. The waterfall view displays the downloading of objects, similar to what you see in the page load test. API tests monitor how your APIs perform from anywhere in the world using cloud agents or enterprise agents. They send requests to your API endpoints to measure uptime, response speed, and validate the data that comes back. You can also chain multiple requests together to simulate complete workflows, like logging in and then fetching user data. The built-in step builder walks you through setting this up. In the API test views, you'll see your API transaction times alongside underlying network performance metrics like latency, loss, and BGP routes. A geographic map and timeline help you spot regional issues or performance trends over time. For multi-step API calls, you can drill down into each individual step to see its performance and outcome. RTP stream tests emulate the flow of voice data between two agents, simulating an IP voice over IP call. They measure voice over IP health metrics including packet loss, discards, latency, and mean opinion score, or MOS, a measure of voice quality. The primary metric is MOS, which assesses the quality of voice traffic. You can also view the other collected voice metrics. The path visualization shows a step-by-step breakdown of each hop, and the BGP route visualization displays route details from public monitors to the target destination. SIP server tests assess the availability and performance of SIP voice over IP servers. They confirm the ability to perform SIP registration with a target server and observe the underlying requests and responses, helping you identify issues related to server reachability, registration processes, and overall SIP communication. The primary metrics include availability, the percentage of time the service successfully responds, response time, time until the first byte of the response is received, and total time, the complete duration of the test, including DNS resolution, connection establishment, and SIP registration or options processing. That wraps up our overview of network and app synthetics test types. We've covered the basics of how these tests work, their use cases, and when to use them. Thanks for watching.